Hi all. So recently I had the chance to purchase one of these boards from a local store. So this costs around 500 pesos. So that would be around 10 US dollars. This is actually an ESP32 board with an OLED LCD right here. So OLED actually has an advantage over the common LCD because you don't need any backlight. So the objects or the text or the graphics on this LCD would still be visible even if there's no enough light or if there's no backlight included. Um, so this board right here is powered through a micro USB port like this one, similar to the ordinary ESP32 board. It also comes with a JST connector, if I'm not mistaken. You connect here a lithium battery. So if you purchase this one, it would have this connector included. Okay, so you can just plug it right here. Then you can connect your lithium battery here. Also, uh, it comes with this header. So I've already soldered the headers here. Okay, so the board comes with the headers, this connector, and so on. So if you look at the board, okay, so it has a charger IC. That's right here. This one, the small one right here. This is charger IC. This is for lithium batteries, and it accepts a 5-volt input, and the output voltage for the battery is around 4.2 volts. So your battery should be around 4.2 volts. Okay, so basically, if you connect your USB cable here, connect this to a source, either from a computer or from a wall adapter, that 5 volts would be the source of the power for this charger IC. Then it would charge the battery connected here. Okay, and then you have your USB serial IC here. This is a CP2102, and so in order for this board to communicate with your PC, you need that driver, and I will be giving the link to the driver if your computer doesn't have that driver yet. Also, you have your regulator here. I believe this is a 5 volts to 3.3 volts regulator because, as I mentioned, power here comes from a 5 volt USB, although it could also be from the battery, which it should be 4.2 volts. So this regulator here drops the voltage to 3.3 because the ESP32 runs on 3.3 volts. Okay. Also, this OLED LCD, as I've read, is powered by an SSD 1306 controller. So any library that uses that controller would be useful here. Okay. Then you have your usual boot button, this one, the boot button, and you have your enable button here. Okay, and then the usual ESP32 pins. Okay, so that's about it for the board. Now let me just show you how to set this up. Okay, so if this is your first time using the the ESP32 board, first thing you need to do is to download the CP2102 driver so that your ESP32 board can communicate with your computer. So depending on your OS, you can download the drivers in this site, the CLab site. Uh, so for example, for me, since my OS is Windows 10, I'll download this one. So it's around only 2.3 IMBs. Okay, so after you download this one, then hopefully your computer will now be able to detect your ESP32 board once you plug it in your computer. Okay, so after that, the next thing you need to do is open your IDE. Okay, so we need to code this ESP32 board using the Arduino platform. So the first thing is go to File, then go to Preferences. Okay, and look for the additional boards manager URLs. Okay, so here I have multiple JSON files or JSON links. So if you already have your JSON links here, I suppose you already know how this is done. So just click it here. Okay, then what you need is to add this URL. Okay, so this is the URL for the ESP32 boards. Okay, for the supported ESP32 boards on the Arduino IDE. So once you have this link right here, just click OK, and then click another OK, and then you should be able to search now for the ESP32 boards. So that would be on Tools, Board, and go to Boards Manager. Okay, so you just search for ESP32 here. Okay, so just use the keyword ESP32. Then you will have this result, search result. Then for me, it's already been installed. But if you don't have it installed yet, there would be another button here. It's called an install button. It's an install button here. Then you click install. Then this board package now would be installed on your computer. And that would enable you to select the ESP32 boards here. Okay, so basically the ESP32 boards would appear here. And for this board, although this has an OLED, included OLED LCD, you'll actually just select the Wemos Lolen 32 board, and that would be already the board or the package for this kind of board right here. Okay, so select that one. Okay, that's it. Alright. Next would be for using the LCD. As I mentioned, this LCD is Wemos Lolen 32, right? SD1306 controller. So any controller, any library that uses controller can be used with this one. So for me, I selected the one from Adafruit because aside from the SSD1306 library, it also has support for the Adafruit graphics library, which actually is very useful if you want to build graphics using this LCD. So to do that, we just search for the library. So you go to Sketch, Include Library, then you go to Manage Libraries. Okay, so the library manager would appear, and then you just search for Adafruit SSD 1306 library. Okay, so search for that, and this would be the library I'm talking about. So again, for me, it has been already installed. For you, if it's not installed yet, there would be an install button right here. Then you just click install, and that would install the library in your computer. Okay. Now this library has lots of examples. So let me just show you. So go to File, Examples, then search for that library right here. So you have around 5 examples. You have the for the feather wing and for the different versions of the SSD 1306. For this board, you should select the SSD 1306 128 by 64 I2C example. Okay, so if you click this one, this would be the example. Okay, so this actually is a 128 by 64 board. Okay, so that means it has 128 pixels horizontally and 64 pixels vertically. Now you need to modify this board because if you upload this, it will not actually run on your board right here, because if you look at the code, it uses an instance of the WAR library, and if you don't specify this WAR instance, it will default to the default I2C pins for the Arduino. Okay, and the default I2C pins for the Arduino, Arduino Uno, Mega, and so on, is not the same for the ESP32. So if you leave it as is, it won't run. So you need to add something here so that you can use the I2C pins of the ESP32 instead of the I2C pins of the Arduino. Okay. Also, the I2C address of this OLED I2C is 3C. Okay. So you can actually use an I2C scanner. There's some sketch in the web for that, but I'll just share it to you, to save you some time. The I2C address for this board is, or for this LCD is 0xTC. Now going back to specifying the I2C pins for this LCD and towards the ESP32, let's go to setup. Okay, so you see the example actually is using the 3D address, so just need to change this to 3C. Okay, 3C. Then before this one, you can just create an instance of the wire library. Okay, then you click begin. Then for this one, it needs the SCL SDA pins, the I2C SCL SDA pins as parameter. For the ESP32 and for this board particularly, the SCL pin is pin 5 and the SDA pin is pin 4. Okay, so once you specify this one, this would be the instance that will be used on your initialization of the display class. So instead of using the default Arduino pins, then it would be using the pins 5 and 4 of the ESP32. And also, by the way, this pin has no reset as a pin. So here it's declared as pin 4. So you just change this to pin 1. Because as for the instruction, you should be placing -1 if sharing the Arduino reset pin. So this one is sharing actually the ESP32 reset pin. So just change the OLED reset definition to -1. Okay. So this actually is a demonstration of all the capabilities of the Adafruit graphics library. So let me try to upload this to my board. So I have my micro USB cable here already connected to my computer. So I'll just this right here. Okay.
Hello.
Yeah. So that's my computer speaking. So I'll just click the. Of course, I need to check the port. So it's already correct. It's COM3. My board is correct. And the rest is correct. So just click upload. Okay. Now, weird thing with this P32 boards is that you need to click the boot button if you see the connecting text here as it uploads. So let me just show you. So wait for the connecting text to appear here on the IDE. Okay, that's connecting. So just click on the you press and hold the boot button, then you release, and that should upload the code to the Arduino IDE. So it says that it's done uploading. So this is now what is on the LCD. So it's actually a demonstration of all the graphic capabilities of the library. Okay, so I hope you can see it. Yeah, so that's some ovals. Okay, so that's triangles. Okay, and that's the text. Yeah, that is text. Hello world. Let's scroll. Okay. So yeah, so with that, we can now use the Adafruit graphics library with this LCD, and I'll show you some basic examples. So actually, the advantage of this board is that you can use the LCD, of course. Then you can also use the Wi-Fi or Bluetooth capabilities of the ESP32. So that's one advantage. So for my next example, I'll show you how to integrate the Wi-Fi capabilities of the ESP32 and then also the OLED LCD screen. Okay, so for my example application, so let me show you first the output. So here I have some text written on my OLED LCD. So it says actually connecting to Wi-Fi. Then you have the word connecting. Then you have your IP address 192.168.1.67. Then another text that says HTTP server started. So hopefully you can get it to be clear in the camera. Okay, so what this does is actually create a web server using the ESP32, and then you can connect to that web server using the provided IP address. So if you use your browser, providing that your computer and use your ESP32 uses the same network, okay, and you can you can view what's on your server. So 67. So here I just written hello, a very basic example. Okay, so the code for this one is right here. So what you need is only the Wi-Fi library. So we have here my Wi-Fi library, my Wi-Fi client, my web server. So if you already installed the ESP32 package, then these libraries would be included there. Okay. Then the rest are for the LCD. So you have your SPI. Actually, you don't need SPI here. You can remove this one. You have UR. UR is needed, of course, because you will be using the I2C LCD. Then your Adafruit graphics library, and then your HD1306 library. So here it's actually the same for our previous example. Okay, so you specify the OLED width and height, that would be 128 and 64. Then your reset pin, you make it -1 so that your screen will share the same reset pin as your ESP32. Then your initialization of the display class. Okay. Then of course you have your var instance here and here, right here, and then you have your var that begin here, which specifies your SCL and SDA pin. So this is important so that your LCD would be working on your ESP32 board. And again, the address should be 3C right here. Okay, so that should be 3C. Now, for the web server, as you can see, I provided here my SSID. Okay, so this is my SSID and this is my password. If ever you can go to our house, you can connect to our Wi-Fi. So since you already know my SSID and my password, okay, providing that I won't change it, of course. But so that's you need to specify your SSID and password so that your ASP32 can connect to your Wi-Fi. Okay. Then you initialize the web server class. So we use port 80 because we'll be using HTTP. Yes, HTTP. Then an empty string message. By the way, this code is actually a remnant of my older code. So basically, I just copied that code and then combined it with the LCD code so that we can work with the LCD and the web server at the same time. Okay, so here for you clear the display and so on and so forth. Then for the server, um, we specify it as a Wi-Fi station because we have a web server. So the other things here could be a Wi-Fi. Aside from a server, you can also use your SP32 also as an access point wherein you can connect it. You can connect to it like a router. Okay, so the SP32 will be providing the SSID and you can specify also the password. So basically, you'll not be connecting now to the router using your phone. You're connecting to the ESP32. Okay, but for now, for this application, we need the ESP32 as a Wi-Fi station so that it needs to connect to a router with an internet connection. Then we begin the Wi-Fi, providing our SSD and password. Then here, this is the point where the connecting to Wi-Fi text is displayed right here. Okay, so basically, if it's still connecting, it should show a series of dots. But here, you only see one dot. So that means the SP32 instantly connected to my Wi-Fi. I don't know if that's the speed of the ESP32 or the speed of my Wi-Fi, my router. So, but actually tried experience using the ESP8266, the older ESP board. So it actually takes longer to connect to the Wi-Fi. So this one is actually much faster. Then once it's connected to the Wi-Fi, it will display the string connected right here. So you also see the connected in the second line, although it might be blurry on the camera. Then it will display the IP address of the ESP32 board because we need this to access the server on our browser or whatever that we needed it for. Then my server actually, the contents of my server is basically just a hello, okay, a heading, H1 header with hello. So that's why here you see only hello, okay. So this is the contents of my server, hello. But obviously you can change this one. You can actually make this a variable and create a whole HTML page with anything you want. No? Actually, I have my projects in my website for that. Maybe one day I could share it here. So here I just use a simple string hello. You can again you can change this to whatever HTML page you want to display in your server. Okay. Then start web server. You just use server that begin. Then it will display the last text here, which is that's the text HTTP server started. So it will start the server. Now basically, this is just a setup. So this runs only once. On your loop, you have your server that handle client. Okay, so it's a loop because you want that every time a client, for example, if I visit this website, I became the client. So the handle client function should be on the loop so that the ESP32 can always check if there's a client visiting the server. So, for example, I'm the client. So, if you won't place this in a loop or you create a delay for the handle client function, then there would be a time where the ESP32 could miss your client. So, it's better that your handle client should be within the loop. Okay. So, that's about it for this example. So, this is just showing you the server information so that your user could connect to it. And this is very handy because you don't need to open the serial monitor anymore. You can just view the IP address of the server right on the screen. Alright, so for my next example, I have here a simple project wherein I acquire weather data from an API somewhere in the web. Okay, so here you will see some text. It says partly cloudy. Then you have the okay, I hope I can make this clear. You have your temperature, your wind speed, your precipitation, and your humidity. So these data are coming from a web API. So how did I create this one? So basically, I went to this website, weatherstack.com, and then once you sign up, just actually you have an option to pay or go to the free ones, but I choose the free one. So once you uh, sign up, you will head to this dashboard right here. You will have your API key, and then you have a sample request here. So basically, you just call this URL and you specify your access key and your location, and it will provide you the weather updates of that location. So you can make this current request, historical, time series, or forecast. So for this one, I use the current request. So basically, this should be my request URL. So this is it. Okay, so this is the API URL. So my access key and then my location. So if I press the enter button. So it provides a JSON string where we can acquire the weather information. So you have your description, your wind speed, wind degree, pressure, precipitation, humidity, and so on and so forth. So there are actually a lot of information here, including the location or the latitude and longitude of the location, the time, and so on and so forth. So there's a lot of information actually. Okay. For this one, I needed a couple of libraries, new libraries for the ESP32 because one, we need to parse this JSON, and two, because actually this is not the only thing that the server will give you when you request this URL. Let me show you. I have here, basically, when you do a GET request like this one, this is what you will send to the server, this right here, this string right here. Okay, so if I will simulate this with, say, Putty, a terminal application. Okay, so I have here row, then my host would be api.weatherstack.com, and then port 80. Okay, so open, and I paste that request. So the server will reply with this one. So as you can see, here's the JSON, but then again, there's other strings here, like this is the server response, right? But I only need the JSON string. Okay, so besides the JSON parser, I also need the Arduino HTTP response library so that I can filter the response from the server and just acquire this JSON string right here. So my sketch now is this one. Okay, so I use the same libraries before, same from the previous example, but then I added two libraries, Arduino JSON and the Arduino HTTP client. Okay, so this parses the JSON string. This one filters the server response so that I only get the JSON data from the server. Okay, so these parts are the same. Just to initialize the screen, my Wi-Fi ID and password. Now here, I specified my host, which is api.weatherstack.com, my location, which is Davao City, and my access key or my API key, which is this one right here. Then I specify a string URL so that I can just string this up all together for my request later on. Okay. Then I need to have a JSON document. This is actually a sort of buffer. Okay. So this uses the memory or the RAM of the microcontroller, the ESP32. And this serves as a temporary storage while we are parsing the JSON. So this is actually important. You put two small values here, you will have an error in your sketch. Okay, it will not show here on in the terminal in the Arduino IDE, but it will definitely affect your code when you run it. So I suggest you go with a larger value. So if you're using ESP32, ESP32 has 52 KB of RAM, so you can just use 2048 or 4096. So for me, 2048 works. 1024 did not work, so 2048 was my lowest value that can be used, so I used this one. Okay, then I used a Wi-Fi client class, then HTTP client. So the Wi-Fi client is from this library, Wi-Fi client. The HTTP client is from this client, this library here, this one. Okay, so make sure you have this before you can use this. Okay, so basically just give the parameter your Wi-Fi client as your first parameter, your host name, which is the API host, then your port, which is 80. Okay, port 80. Then here you just again specify the I2C pins for the display. Okay, you create the display instance specifying that it should be 3C. Then you set the text size to 1, the font color, where should you start, okay, and so on and so forth. So to make the weather data continuous, okay, so we place the request, the get request or the server request inside the loop so that the ESP32 will continue to request the data. Okay, Because if we place this inside setup like we did before, then it will only run once, right? So I place it inside loop, just a small delay of 2 seconds. Okay, I set the cursor again for the text to start at the upper left. Then this is the get request right here. So remember our URL is this one. Okay, so basically the HTTP client library just uses the URL and also the host name automatically. So this serves as your get request. Then it will respond similar to what you saw on Putty in this one, but since we are using a special library, we can just use the response body function so that instead of all this response, you will only get the body of the response, which is this one, which is our JSON file. So this I place this into my string JSON. Then to parse the JSON, we use the serialized JSON function from the Arduino JSON library. So its parameters are your buffer, doc, and your JSON string. So this returns an error. So just in case you have an error, your LCD display will print the error here. It will tell you actually what the error is about. So earlier, uh, I used a smaller uh, doc buffer here. So it actually returns an error saying that it has not enough memory. And since I printed it on the screen, so the error was shown on the screen. But here I have no error. I have solved that error. So the problem is just I declared a smaller value of the buffer. Okay. But then again, this works. Okay, this works. So just in case you have an error, so I suggest you uh, let this part of the code be. Then to get the data that we want. Okay, so I created some variables here. I have my description, which is a pointer, a char pointer. I have my temperature, my wind, my precipitation, my humidity. Now, looking back at our JSON data here, okay, so if you look at our JSON data, there are actually three parts. You have the request, okay, you have your current, and you have your location. So why are these the three main requests? Because you can actually see that after them you have your opening and close bracket. So this one is one part. Here so location, in the location you have another part. Okay, so you have your opening and close brackets. Then for the third location you also have your opening and close brackets. So these are three locations. So these are like your main nodes for your JSON data. Then since my data is under the current node right here, so I'll just specify it in my code as current, and then I'll just get whatever I want from this node, from this current node. Okay, so first is the weather description. So I have here the weather description under the current node, but since it's closed in a square bracket, that means it could be in an array. So I just specify 0 here to indicate that I want this first array or this first content here partly cloudy. I mean, okay. So I place 0. Okay. Then next I want the temperature, so I just write temperature here, which is right here on my current node. And then for the rest the same, no? For the wind speed, the precip, the humidity. So just make sure that the string names are the same with your JSON data so that you can acquire the data right away. Then I displayed the data here. Okay, the description, the temperature, the wind, the precipitation, and the humidity. And uploaded that code, and this is what it shows. Okay, so it's just plain strings. We can actually make this better by using graphics, since we are using the Adafruit graphics library. But basically, this is just a demonstration on how to get data from a web server using the Wi-Fi capabilities of the ESP32 and, of course, the OLED screen.